Okay, so now we're working with permutations. Let's read through the question carefully and look for important information. Erica bought a bike lock, but she forgot the code. The lock has 4 dials of numbers. Each dial consists of the digits 0 through 9. How many different 4-digit codes does Erica have to choose from to open her bike lock? Alright, so it looks like we have a 4-digit code, and each digit can be anywhere from 0 through 9. So what we're trying to figure out is how many different codes does Erica have to choose from to open her bike lock. Now, it's important to note that a permutation is not the same as a combinations. With combinations, we weren't worried about the order that items appeared in. But in permutations, the order is important. Because say, for instance, Erica's bike lock code is 1, 2, 3, 4. That's not the same as putting in the code 4, 3, 2, 1, even though that's the same combination of digits. So right now we're trying to figure out how many different permutations of the digits 0 through 9, if we have 4 of them, how many different permutations can we have? Okay. One important question that you have to ask with permutations is whether repetition is allowed. So, for instance, sometimes with permutations, we wouldn't be allowed to do 1, 1, 1, 1, but sometimes we can. So, in this instance, we are allowed to do 1, 1, 1, 1 because we have the digits 0 through 9, and each of the 4 digits can be any of those. So let's see how I would approach a problem with permutation when repetition is allowed is consider our 4 slots. So we had 1, 2, 3, 4. So how many options do we have for the first digit? Well, we have the option of the 0 through 9. So that's 10 different digits. So we have 10 options for the first one. How many options do we then have for the second digit? Well, again, we have the option of the digits 0 through 9. So we have 10 options for the second digit. So similarly, for the third and fourth digit, we have 10 options. So if we took the 10 options for the first digit, we then multiply it by the number of options we have for the second digit to give us the options for the first 2 digits. Again, we can multiply again to figure out how many options we have for the first 3, and multiply again for all 4. So what we have is the number of options that we have is 10 to the 4th, or 10,000 different options. So it looks like it'll probably be pretty difficult for Erica to find the right combination very quickly. So just to recap, what we ended up doing was looking at whether this was a permutation or a combination, and we decided it was a permutation because the order mattered. And then we noticed that repetition was allowed. And so for our answer, what we took was the number of options for each digit and simply multiplied them together. So since we had 10 options for each digit, we ended up looking at 10 to the 4th, which we said is 10,000. So there are 10,000 different options for Erica to choose from.